So a midsegment is a segment formed by connecting the midpoints of any two sides of a triangle. So in our picture, I'm going to mark here and here because B is the midpoint. Then I've got these two because E is a midpoint. So it's midpoints of sides. So we have to pay attention to where the sides are. So in our picture, go ahead and get your highlighters out. In your picture, the midsegment is a segment formed, which is right here. Okay. The segment is connecting B and E, and B and E represent midpoints. So B and E are our midpoints. Notice how we marked B's equal and B's equal. So the midsegment is the segment. It's going to go through the middle of the triangle. A midsegment is always inside of the triangle. Always. It's never going to be outside. It's never going to be a side of the triangle. It's always inside. Now, since the midsegment goes through the middle, there is an important formula on how to find measurements of midsegments. Now, it's going to look a little intimidating because there's going to be a fraction in there, but mathematically, getting rid of the fraction is not difficult. Okay, we're going to get a lot of clearing the fraction practice. Okay. Midsegments are also parallel to the side it doesn't touch. So notice how that orange line is going through these two sides of the triangle. It does not touch this bottom side. The midsegment is always going to be parallel with the side it doesn't cross. So in our formula over here, we're going to make a little note. That segment BE, which is our midsegment, that's parallel to what other segment in our triangle? What's the name of the side that's DE? CD. It doesn't cross CD. It doesn't touch that side. So BE is parallel to CD. Okay. What? Yes, so this crosses AC at B, which is a midpoint. So this segment cuts this segment in half and this one. So it's a bisector, basically. So whatever side it doesn't come in contact with, it's parallel to. Now, our formula is the midsegment length, and the midsegment is equal to 1/2 of the parallel side. So we have to know our pieces of our problem to be able to actually solve these. So in your picture, the midsegment is here. That is segment BE. Notice down below that there's variables and stuff in there. We're going to be solving equations. So the midsegment is half of the measurement of the side it's parallel to, which in this case is CD. So our midsegment measure is half of the measure that it's parallel to. And just by looking at that picture, you can tell that that orange segment is smaller. Okay? Usually we don't assume things in geometry, but for midsegments, it looks smaller because it is smaller. So I will let you assume that information, okay? So the midsegment is half of the parallel side. So let's do one where it's just some numbers. So I'm going to draw a little triangle. I'm going to draw a segment. And that little segment is going to represent our midsegment. Okay. The midsegment is half of the parallel side. So I'm going to make this parallel side 10. So we'll make it 10 centimeters. We have units. Units matter. So 10 centimeters. How do I find the midsegment? If the midsegment is half of that measurement, what is it? Divided by 2. So anytime I'm trying to find this measurement in here, Basically, I take this measure and divide it by 2. So if I'm going in here, I'm going to divide by 2. So 10 divided by 2 is 5. What if I have the midsegment and I want the side? What should I do then with the 5? If I want to find the measurement of the side. How do I get from 5 to 10? Times 2. So if you have the midsegment and you're going out, you multiply by 2. Going in, you divide. Going out, you multiply. And when we get to circles, we're going to use that a lot. Okay, the division and the multiplication. So the midsegment is half of the side it is parallel to, which is where the 1/2 comes into play right here. Okay? So let's try some algebra. So we're going to go down to number 1 before we get into actual equations. Okay, number 1. We want to solve for all those variables. We want to solve for all our variables. Okay. What does segment BE represent? What do we call this segment, BE, right here? Midsegment. Okay. The midsegment is parallel to what side of our triangle? Parallel means they're going the same direction. They're not crossing. CD. So we're going to put arrows because arrows mean parallel. Okay. So what does that make points B and E? If they're connected to a midsegment, what do we call points B and E? Midsegment connects what 2 points on the triangle? It's in our definition. The midsegment connects what kind of points? Midpoints. So B and E are midpoints, which means AC is cut in half, which means BC and AB are equal because B is the midpoint. What other 2 sides should be the same measure? Okay, AD has been cut in half by point E. So we have segment A to E gets 2 bars. E to D gets 2 bars. So the first thing we did was label all that info on our picture. Drawing on the picture makes these problems a lot easier. Okay. So we have variables Y, Z, X, W, and V. Which one do you want to solve for first? Okay, you want to solve for Y first? So Y represents the whole entire segment. So to use segment addition, I have to know the 2 smaller pieces. What are the 2 smaller pieces? One of them is a 7. What is Z going to be? Z is 7 as well. Good job. So I'm going to write a Z here equals 7, and then over on my answer, I'm going to put 7. Now that we know Z, now we can solve for Y. So what is the value of Y? Yeah. Because B is a midpoint. So midpoint means middle. So whatever half of it is, the other half has to equal that too. Okay. So to get segment AC, which represents Y, I have to use segment addition postulate by adding the 2 small pieces together. So I have to add, what is it? 14. BC plus AB is 14. Because 7 plus 7 is 14. So what's happening in these problems is you're looking for things that you learned junior year. Segment addition postulate, midpoint. All that stuff you've learned before. So let's hop on over to the other side. We have W and V. It tells you that A to D is 22. So how can I find those 2 small pieces of W and V? If point E is a midpoint, think of it like a sandwich at Subway. You have a 12-inch sandwich, but I want to break it into 2 parts. So what do I do with the 22 to break it into two parts that are the same? I'm trying to read the hand signs that you're throwing up in the back. Divided by what? 2. We want to cut it in half. E is the midpoint. It's in the middle. Okay? When I use a midpoint, I cut it evenly in half. If I'm going to split a sandwich with you, I will split it 50-50. I'm not going to take more of it. So 22 divided by 2 is 11, which means this segment has to be 11. And this segment has to be 11. So W and V are both 11. Because half of 22 is 11. All right. How do we get X? Yeah, take 10 and divide it by 2. We're working into our problem. The mid-segment is half as long, so I divide by 2. So 10 divided by 2 is 5. Remember, X is the mid-segment of your problem. This mid-segment. And then going back up to the picture up top, this is the parallel side, which means that mid-segment should be half of that measurement. So use that information that we just did on number 1 to do number 2. All right, so on here, let's pick a variable. I'm going to start with X. What did we get for variable X? What, Christian? 16. For X, we get 16 because J is a midpoint, which means that these two are equal. And on a lot of your pictures, I saw the lines, which is important. So this is 16. Make sure that you're writing that on your picture. It helps you. All right, let's move to Z. How does 16 and 16 help us find Z? 16 and 16, we're looking for Z. How do these two help us find this segment? Yeah, so you segment addition postulate. You add 16 plus 16, so what is that?
32.
32. So Z is 32. Now let's hop down to W and Y. How can we use 28 to help us with W and Y? Divide them by 2. Good. Again, these have to be equal. So 28 divided by 2 is 14. So both of these should be 14. You can always test yourself. 14 plus 14 does equal 28, so you know that you divided correctly. What about V? Times it by what?
8.
No, V can't be 8.
No, 8.
Oh, 8 times 2. Yes. Sorry, I didn't hear the 2 parts. So 8 to go out, I multiply by 2 to get 16. So things you need to be aware of. On your problems, look for the mid-segment. Remember, mid-segment is always the smaller one. So if I'm going out, I need to multiply by 2. If I'm going in, like in the first one, I divide by 2. So let's talk area and perimeter. So area, okay, if we're talking in terms of area is like if I wanted to cover the floor in carpet or in tile. Perimeter is if I want to put a fence around something. So perimeter is like adding up all the sides on the outside, and area is like covering a floor. Okay? Now, mid-segments have interesting information regarding areas versus perimeters. Okay? So in our picture, this looks a little bit different from what you're used to. Usually, we only have one segment through the middle. Now, I have 3. So there are 3 mid-segments in one picture. So to talk about area and perimeter, we have to first talk about what is equal and parallel. So this whole thing right here kind of all goes together. So to help us, let's identify our mid-segments. Okay? So I'm just going to start with this first one. BF is a mid-segment. Right here. What side is BF parallel to? What side is BF parallel to? Okay, D, did you say DE?
C.
Oh, CE, yes. All right, I cannot hear you. It's parallel to this one. That whole piece. So down below where it says BF is parallel, we're going to put CE. BF is parallel to CE. That parallel means same direction, never crossing. Okay? Now, something interesting happens with the segment CE. What kind of point do we think point D is? A midpoint, good job. Because in this picture, we've got a bunch of mid-segments. And remember, mid-segments connect midpoints. Mid and mid. So what that means is this segment and this segment aren't equal. Because D is in fact a midpoint. Is BF equal to CD and DE? The segment of BF, is this segment the same as these two? I'm trying to read your mind. And I hear you say, yes.
Yeah.
Yeah, that's what you meant? Okay, so let's draw a little picture to confirm the unsure yes. All right, so let's say that this is, again, we'll say 5. How long is this segment? The whole thing. How long is this big one? This is our mid segment. How long is all of it?
Okay.
10. Now what if I put a midpoint in there? 5 and 5. So is the mid segment equal to those 3 little pieces? Mm-hmm. Yes, all 3 of these are equal. So when you start to include more mid segments, you have more congruency in your picture. So that means that segment BF is also congruent to CD, and it's also congruent to DE. Because everything is a midpoint, so everything's getting cut in half. Now, that same idea follows through depending on what mid-segment you're looking at. So if we look at segment BD, that's another mid-segment. What side is BD parallel to? AE. Or EA, you can write either one. And I realize I skipped FD, so we're just going to hop down to the bottom and put AE right here. All right. So now we should know we've got another set of mid-segments with more midpoints. What 3 segments are now equal? What 3 little segments are now the same measurement? Look at our yellow to kind of guide us. What 3 segments should now be the same measurement? F what? Okay, AF. What? FE? And BD. There you go. So BD, which kind of got chopped off here at the bottom, is congruent to AF and FE. So we have 3 little tiny pieces. Okay. One more set of mid-segments. Okay. Our next mid-segment, let's make it, is FD. What side is FD parallel to? AC. So FD is parallel to AC, or you could write CA, completely up to you. Highlighting it makes it a lot easier to see, especially when there's a bunch of stuff going on in your picture. All right. What 3 little segments are now the same? Okay. FD, AB and BC. All the little ones are the same, and we're putting 3 bars this time because this is our third pair. The more mid-segments you add, the more congruency you have. So let's talk in terms of area versus perimeter. The state test loves these questions because they think that they're difficult. But if you understand what a midsegment does, the math is really just dividing. Okay? So let's say that the area of our big triangle, and our big triangle name is ACE. That's our big triangle. Let's say that the area, and I'm just going to make something up, okay? The area of triangle ACE, let's say, is 40 centimeters squared. Now, we haven't really talked about area in much detail yet, but we will. But area just means if I wanted to cover the entire floor of this triangular house, I would need 40 square centimeters of tile or carpet, okay? Now, what if I want to find the area of just this little tiny triangle? Triangle FDE. Okay, so let's say that the whole entire triangle has an area of 40. But only one of those small triangles I want to know the area of. What should I do with the area of all of it if I just want a little part of this one? So let's think about the triangles. What do we know about all 4 of these triangles? Are they different sizes, same sizes? They're different sizes, each of those little tiny ones? They're all the same size. They each have a yellow, a pink, and a blue. Yellow, pink, blue, yellow, pink, blue, yellow, pink, blue. All those little tiny triangles, they're exactly the same. How many are there? 4 of them. So the area of all 4 of them together is 40. I only want the area of this little tiny piece, just one piece. What should I do? What?
40.
Yes. Yes, 40 divided by 4. I want to break up all that area, and I want to break it up into 4 equal parts because these are all the same. So the area of just one of these little ones is 10. All you do is divide by 4. Because all 4 of those little triangles are the same. So the area of the big triangle is 4 times bigger than the area of one of them. So if I give you all the area and I just want a little triangle, I would divide by 2. What would the area be of 2 of these triangles together? I want the area of both of these. How much would 2 of them be? 20, because 10 plus 10 is 20. Now, perimeter, a little bit different. Okay. Perimeter is like fencing around a yard or a house. Okay. So perimeter is all about side measurements. So let's say that we've got, again, our big triangle. Our big triangle is ACE. Let's say that this side is 10, this side is 5. Actually, let's make this side 6. That's a terrible 6. I'm going to fix it. Make this little side 6. I'm going to make this side 24. Okay. So what is the perimeter of triangle ACE? How do I find the perimeter of a shape?
Add together.
Okay, add them together. So what is the perimeter of this shape? Perimeter of this shape is 40. So ACE, P stands for perimeter. It's 40 centimeters. Now, when you do perimeter, you don't square it. Now, using this information, we want the perimeter of just a little tiny triangle right here. This is triangle FDE. So what you have to do is kind of look at the big triangle, CE. The big triangle side is 6. So let's start down at the bottom. CE represents this whole entire thing. It's 6. I need to know what DE's measurement is. So how do I find that? It's 3. How did you get 3? Yeah, divided it by 2. Good job, because it's half, right? If the whole thing's 6, half of it's 3. All right, what is the length of FD? Good, it's 5 because AC is this whole thing and it's 10. What about FE? 12. Half of 24 is 12. So what is our perimeter of triangle FDE? Okay, I'll forget it. So we want the perimeter, we're adding all the sides up. 20. Good job. So just scoot this over. This is 20. So how can we use the perimeter of the whole entire big triangle to get to the perimeter of one of the tiny triangles? What could we do with the 40 to get to 20? Divide by what number? No, 40 divided by 4 is 10. You're on the right track. We want to get to 20 though. 40 divided by what? 2. So 40 divided by 2 is 20. So the perimeter is half. The little tiny triangle is half the perimeter of all of it because it's made up of all the half pieces. It's half of all the measurements. Okay? So down at the bottom, we're going to try to put everything together. This is AF. It got chopped off in the copier. The first thing I want you to do is mark this picture like you did up here, where we've got the blue, the pink, and the yellow. So the first thing I want you to do is mark the mid-segment with the side and basically replicate the markings that we have up here. All of our pieces together. Let's fill in all the missing blanks. So let's start with FD. How can we find the measurement of FD? This measurement right here.
It's the thing as long as that. Was that 7.52?
No, not 12.52.
I said 7.5.
It's not 7.5 either. It's 11. How did you get 11? 22 divided by 2. So remember, this length is the parallel side. So 22 is the parallel side, which means to get to its mid-segment, I have to divide by 2. So 22 divided by 2 is 11. All right. How do we find AE? AE is this a big piece right here. Yes. 12.5 times 2, which is what? 25. So this is the mid-segment. To go out, you multiply by 2. So this length is 25. What about CE's measurement? Yes, 7.5 times 2, which is 50. Remember, 7.5 is the mid-segment, so when I go out to the whole thing, I multiply by 2. What's the measurement of CD? What? 3. What?
I divided by 5.
Oh. Yeah, we're trying to find this piece. What is it? Yeah, 7.5. That sounds better. Because remember, D is a midpoint, which makes those two sides equal, so 7.5. What's AF? 12.5. Good job, Haley. What's the perimeter of ABF? The perimeter of triangle ABF. ABF's right here, but I'm missing this little blue piece. I need the perimeter of ABF. How do we find that little blue piece? What'd you get? 31 is right. So, what'd you find for AB? 11. 22 divided by 2 is 11, which means if I want the perimeter of that little tiny triangle up top, I add all the little pieces together. I add 11 plus 12.5 plus 7.5, and I get 31. What's the area of ABC, the big one? No, ABC is not one, sorry. That should be an E. ABE. So that's the big one. I should have made that change. This was during quarantine times in March when I was filming this for my standard class. So no one was correcting me on my mistakes because no one was paying attention. So ABE, wait, what am I saying? That should be A. It's a struggle, guys. This is a struggle. All right. I want it to be ACE. It's okay. Just work with me. It's fine. It's not a big deal. So much for finishing strong. did not happen. It took me 4 minutes to mess up. So.
That's 40.
Okay. Wait, it's 48?
Maybe.
Wait, you want all of it?
I said plus 4.
You say plus 1?
Yeah.
It's okay. I'm not going to say anything because I messed up literally this whole time has been a fail. Yeah, 62. Sounds better to me. Says meters squared. No, it says meters. I need to just end. Our lesson is now over. So on Monday, I'm just ending it. I just am stopping now. On Monday.